All right, now let's notice that we are working with dependent samples. Because you see, each rat has a before and after measurement. What we're interested in is in the difference between the before and after for each rat. So the first sample is all the before measurements. And notice the second sample is matched up. These are matched pairs. You cannot be in this second sample unless you've got a direct connection. You're matched up in some way with a data value in the first sample. So they're matched pairs. And what we're actually analyzing is simply the differences between these. All right, so first thing I need to do is get those differences. So on my calculator, turn this thing on, press Stat, press 1 for Edit, and I'm going to put, as you can see I've already done, I've put in the first sample, all the before measurements in list 1, and I put all the after measurements from sample 2 into list 2. And make sure that these are matched up with each other, so it's important to get the order right. So why don't you get out your calculator, hit the pause key on your movie, and enter in your data, and then once you're done, hit the play key and come back here. All right, are you back? Good. So let's see, you should have this. The sample 1 is in list 1, sample 2 in list 2. What we're going to do is we're going to put the differences in L3. This is how we do it. I'm going to highlight L3 here using my arrow keys. Now with L3 highlighted, I am going to tell it to take what's in list 1 and subtract list 2 from it. And how I do that is I press this yellow second key, and then 1, and that puts in L1 here, as you can see. And I'll hit the subtract key, and then I'll hit this yellow second key and 2, and that puts in L2. So it'll take what's in L1 and subtract what's in L2 and put it over here. Do that for all of these when I hit enter. So there's all my differences. This is what I'm analyzing. Now, all these differences, now it's not a large sample size. We don't have 30 or more matched pairs. So if I were to analyze the probability plot, I see that the sample appears to be normal. See, all these points are within the boundaries. And I look at the box plot, I see no outliers. So if the sample is normal without outliers, it's reasonable to believe that the population of differences is normal. So that means we can continue, because the conditions that must be met. 1, that first sample has to be a random sample, and everyone in the second sample has to be matched up with the first one, making these dependent samples. And then these differences, either there's a large number of matched pairs, 30 or more, or the differences, the population of differences is normal. Well, we had a small sample size, so that's why we had to make that probability plot and box plot. Our conditions are met. So, setting up our hypothesis. The null hypothesis is always the population mean of all the differences is 0. In other words, there is no difference between these two samples, the before and after. What we're interested in is if the before measurements are less than the after measurements. Now remember, before is L1, so L1 minus L2. Now that result will be negative if the before measurements is smaller than the after. So that's why we have the differences being less than 0. Now we're going to use a significance level of 5%. And let's get out our calculator, and we're going to run t-test on the differences. So let's get out the calculator. We're going to press Stat, press the right arrow key twice to highlight test, and we want to select t-test. So I'll press 2 to select it. Now, we've got the data in the list. So I got to highlight data here. So I'll press my arrow key and hit enter. And see how this changes here. And this is the hypothesized difference, 0. Now, our differences is in list 3. So I have to press the yellow second key and 3 to put L3 in there. Frequency is set to 1. Now go down here, we've got to tell it what our alternate hypothesis is. And that is that the difference is less than the hypothesized value of 0. So I got to highlight this one here. I use my arrow key to highlight, press enter to select it, go down here and highlight calculate, and hit enter. All right, our test statistic is a negative 2.90. Now, how unusual would it be to get a test statistic like that if the null hypothesis were true? That's what the p-value tells us. P-value here is telling us, hey, that's pretty unusual. That's a pretty small probability. So we would say it'd be very unlikely to get a test statistic like that if it were true. So that's why we don't believe the null hypothesis is true. That's why we're going to reject it and accept the alternate. Let's go back on down to our little document here. So there's our p-value. You can see the p-value is definitely less our significance level. 0.72% is much less than 5%. So our p-value is definitely small enough, giving us sufficient evidence against the null hypothesis so we can reject it. So there is sufficient evidence at the 5% level of significance to support the claim that the hemoglobin levels for male rats before going into space are significantly less than the hemoglobin levels upon their return. When we analyze the population mean of all those differences. Now, let's get an idea of the magnitude of the difference. That's pretty easy to do after you've done a hypothesis test. Follow up t-test with t-interval. So press stat. Over here, press the right arrow key twice to highlight test. And let's go on down here. It's choice number 8, t-interval. So you can just press 8 to select t-interval. Now, if you don't have data already highlighted, hit enter. Go down here. Notice that this will already be highlighted because you've already done t-test. That's why L3 is already in there and frequency is set to 1. Now let's see what confidence level they were asking us to do here. They wanted us to do a 90% confidence interval, so that's what we'll do. Let's put in 0.90, hit enter, and then hit enter. Takes it a little while, but we got our answer, just as it shows right here. Now let's put that into words. And those words are, we are 90% confident that the population mean difference between the before and after measurements for all male rats is between negative 1.47 and negative 0.35 grams per deciliter. So that gives us an idea of how much smaller the before measurements are from the afters. But of course, to know if that's significant, I guess we'd have to talk to an expert on male rats and who's aware whether that difference is truly of practical significance.